delete function or remove function for max heap, and so we write here my max heap dot remove top, and this function is not yet defined, so let's define this function here in the public block, remove top. And first of all, which will check if the heap is not empty. If count is 0, we can say that heap is empty. Heap is empty, and we can return simply null value. And in else case, what we will do, as we have already discussed, let's just revisit the concept. We will remove this top value, and we will replace this top value with the last value of the array, or the last value of the heap tree, that is 14, this way. So this is the first step, and in the second step we will mix this tree so that the next maximum value again comes to the top. So let's perform the first step. We take variable top and put the top value in this variable. Then we replace that top value with the last value of the heap, that is count minus 1. And as the count has decreased now, so we say count minus minus, and then we will return the top value. But before turning the top value, we need to heap down the heap, mix that heap again so that the next maximum value again comes to the top. So that for that purpose we call the function heap down, and it's again a recursive function, and we pass the root index, that is 0, to this function. So this function, what will this function will do? Let's define this function first, because it is a utility function, and so we do not need to define this function in the public block. We will define it in the private block here. Void heap down function, and the argument can be called root because it's 0. We have first time we are sending 0 from here. And in this function, what we will do, let's just revisit the concept. First of all, we will see its both children, left and right, and we will see who is the big brother. For example, in this case 42 is a big brother, so we will then we will compare this big brother with the root, and if it is bigger than root, then we will perform swap. Like in this case 42 is bigger than 14, so we will swap, and where did it go? Oh my god, 14 is here, yes, and 42 will go here and 40 will come here. Next, it has two children, 33 and 31, and again 33 is big brother, so, and 33 again also greater than 14, so again we will swap, 33 will come here and 14 will come here. And again 14 had two brothers, two children, 10 and 26, and 26 is big brother. So we will compare 14 with its big elder child, I mean 26. And as you know, sorry, excuse me, and as you know 26 is bigger than 14, so we will swap. 26 will come at this place and 14 will come at this place. And finally, you know, at this point we do not have any further left or right child, so we will stop here. So this is the procedure that we will follow, and so let's define this procedure in the function heap down. First of all, we define a variable last. It is count minus 1, the index of the last node, because we will stop at the last. And we will define left child and right child. As we have already discussed, left child is equal to root into 2 plus 1, and right child is equal to +2, and let's define a variable big brother. And first of all, here is a base condition for recursion. If left child is less than or equal to last, like this formula gives us left child, and if left child is less than or equal to last, only then we will proceed. If left child is greater than last, then it means we have covered the whole heap values, so we will stop there. So this is one of the base conditions for this recursive function. And here again we check if left child is equal to last. I mean, if left child is the last node of the heap tree, then you know it's the only child, so big brother is equal to left child. Otherwise, else we will compare if left child value at left child index is greater than value at right child index, we will say big brother index is actually left child index. And otherwise big brother is equal to right child index. So this is the first step here, where we are just figuring out which one is the big brother, and in the next step we will compare that big brother with the parent node, and if the big brother is bigger than parent, we will swap, otherwise we will stop there. If value at big brother is greater than value at root, what we will do, we will simply swap. And for swapping, you know, we can take a temp variable, and in temp variable we place array value at big brother, and then we replace value at big brother with value at root, and then we replace value at root with value at big brother, that is in the temp variable. So this is the swapping, and after swapping we will again call this function using recursive method, and this time big brother index will become the next root value. So this is it. This is a heap down function. So let's try our code, test our code, and to test our code we need to write a display function. Let's write a simple display function that is quite easy. For in I is equal to 0, I less than count has the total size of the heap, and I plus plus, and you write a simple cout function where we will display values in the array and add some spaces. So this is it. So let's write some, first of all we add some values. 100 18 180 188, simply 8, simply 9, simply 1, simply 7. So 188 is the maximum value, so it should be on the top, and let's call my max display function. It will display value from left to right, and next we remove some top value, and let's write line break here, just make things clear, and again show the values in the heap. And so let's call this block again. So let's see what happens. First of all, we have all these values. This display will show the maximum value, and on the left that would be 188. Then we will remove that 188. The second largest value is 180. It will be shown on the left. So let's see. First time 188 is on the left, then we removed 188, 180 is on the left, then 18 is on the left, and 9 is on the left, and 8 is on the left. So next time 7 will be on the left. So this way the process will continue. So this was a simple function for deletion or removing top from the max heap. And in the next lecture we will probably going for writing the code of sorting using heap concept, that's called the heap sort. So stay tuned for the next lecture.